Hi guys, and welcome to lesson 3 of our unit, which is a land shaped by wind and ice. Today's lesson is going to be looking at the formation of soil, and this directly follows on from our lessons on weathering and the rock cycle we've done previously to this. As always, your activity is to watch this video and pause when asked, and then at the end there are 3 review questions. I would like you to upload your answers to those 3 review questions at the end of the video. And so to kind of go over the topics we've done so far, we started off by looking at this thing called the rock cycle. And during this lesson, I told you that in the UK there are 3 main rock types. We have igneous, sedimentary, and metamorphic rock. And that rock cycle is really important when we go into later units and understand, for example, that sedimentary rock was very, very soft, whereas metamorphic rock and igneous rock were much, much harder. And what we then looked at was, okay, we know there are these 3 types of rock across the UK, but what happens to them? And then we looked at the concept of weathering, in particular, physical weathering. So we looked at the idea that temperature changes can cause the rock to break down. So if the rock is constantly heating up and cooling, it causes the rock to expand and contract, and it can cause cracks in the rock. We also looked at wind and how wind can cause weathering. And as the wind picks up particles, it can erode the rock like sandpaper, or it can pick bits of material up off the rock and transport them somewhere else. And finally, we looked at this idea of freeze-thaw weathering. Now, in all these processes, the rocks are being broken down in some way. And so we've then got to understand, well, okay, but what happens to these bits of particles? What happens to these sediments in the long term? And the answer to that is soil. So, as our first chance to pause here, here's what I'd like to do. There are 2 questions on this PowerPoint screen. If you have a pen and paper next to you, that would be ideal. I would like you to spend approximately 30 seconds on question 1 and 30 seconds on question 2, and jot down in bullet points some ideas you have what the answers could be. So pause the video now and then unpause it once you've got yourself an answer. Okay, hopefully you've had a little go at that then. So in terms of what the humans use soil for, I'm hoping that you came up with some ideas such as growing plants or growing crops or farming, stuff like that. Really, really good. And for the second question, where does soil come from? The savvy ones amongst you will have realised that it comes from rocks in the first case, and that would make sense because that's what we've been studying so far. But equally, if you weren't too sure on that second question, that is absolutely fine. It's a bit of an abstract one, a bit of a curveball to questions you would normally expect. And so that leads us on to this definition. Well, what exactly is soil? Because most of us have seen soil before. Most of us have probably used soil in primary school, we're potting plants, or at home in your garden. But what actually is soil? Well, soil is a mixture of tiny particles of rock, dead plants and animals, air, and water. So it's a combination of biotic and abiotic factors. We've got dead plants, we've got animals like worms, we've got airs and water in there as well, and we've also got a fair amount of rock. And different soils have different properties. So the soil that we find in our biome in the UK will be slightly different to the soil that we find in the biome in the rainforest, for example, because the types of rock, animals, water, dead plants, etc. will be different, and therefore the soil will also be different as a direct result of that. And so the question we have today is, well, okay, we know what soil is, we know why it's used by humans, but how exactly is it formed? And how is it the case that a soil can be generated pretty much from our 3 types of rock? And so we're going to explore that today in some detail. We're going to look at 4 factors really. Obviously, this is a more simplified version. In reality, there are a lot more factors, a lot more to it. But we'll look at 4 kind of main ways in which our soil is formed. We'll look at the geology. Now, geology is the fancy term for studying rocks. We'll look at time. We'll look at climate, which I've already looked at. And then finally, we will also look at relief. And relief is the word for the height or the shape of the land. If you remember, in our first couple of weeks in geography, we used this word relief when we were looking at OS maps. And relief was shown on an OS map via those contour lines. So relief is like mountains based. That's why I put that icon there to really help jog your memory. So let's start off then. Essentially, this diagram here, we're not going to fully go through it, but what I want you to know is that soil is created from broken down rocks. If we look at our first diagram on the left here, this is showing layers of metamorphic rock. Okay, you can tell it's metamorphic because it's quite packed together and it's got this line here as well. Over time, as you can see, things start to change. The rock is worn down, plants start to grow, and we start to get these two different colours of soil as well. And so we're going to look at exactly how that happens. And if we look at these factors, you can also kind of guess what's going to be happening here. You can guess that it's going to be to do with the weather somehow. But the idea is that soil is created from broken down rocks. And essentially, those rocks are broken down by weathering. So that process of wind, freeze thaw, temperature, among other types of chemical and biological weathering, as those rocks are broken down, small parts of the minerals from those rocks are added to soil. They're creating that soil. And that the rock is called the parent material. Now, basically, a parent material is a scientific name for a weathered rock or deposit from a rock from which a soil has formed. So, for example, the parent material might be a certain type of sedimentary rock, or the parent material might be a certain type of metamorphic rock. And as it is weathered, tiny parts of rock and mineral are eroded away, and that forms the base of our soil. Okay, so it forms that basic part of our soil. We don't need to look at this diagram in too much detail. Basically, it's a very, very complicated process, and we don't need to look into it in that much detail. But if you look at this diagram, you can see that from that parent material, we are having lots of minerals and nutrients, oxides, silica. And basically, that explains why our soil helps plants grow. Because the reason why a plant grows in soil is because they use the soil to take up nutrients. That nutrients comes from rocks initially. So as that rock is broken down, that enables our soil to be formed and our plants to grow. And that's why the rock cycle is so important. Because if we didn't have the rock cycle, if this process did not happen, our soil would not exist, firstly. And if soil didn't exist, we would not be able to grow plants and vegetation, which for obvious reasons would completely change the outlook of ecosystems on our planet. And so that's the first point there about geology. So the rocks are broken down by weathering, and as they're broken down, they form that basis of soil, and they add in lots and lots of minerals as well, which is really, really good. The second thing we need to consider is that this takes time. It actually takes about 1,000 years for just 1 centimetre of soil to form. So you can imagine how much a centimetre is. So it's just about 1,000 years. So it's a really, really long process. In huge parts of Britain, we've only actually had about 10,000 years since the last ice age stripped all the soils away. So you can imagine how we haven't got a huge amount of soil overall. That's why if you dig into the ground, eventually you will just hit rock because there's only a certain layer of soil available. So we need time and we need that geology, we need the rocks. But we also need climate as well. Okay, so we've been studying weather and climate, and then we've studied ecosystems, and we know that the temperature and the amount of water or precipitation is a really key indicator in how much life there is. So, for example, in the rainforest, the soil is really thick and nutritious usually because as it's warm and wet, there is a lot of organic life in the soil. There is a lot of dead plants and animals, there's a lot of insects, and that creates this really, really healthy soil. Whereas in the the tundra, not much water and air enters the soil. There are lower temperature, there's less organic life, and so the soil is far less nutritious, and the soil is a lot thinner as well. So we go back to our definition of soil. which is here, the climate is really impacting this idea about the animals, air and water, and dead plants. Okay, so if we don't have a positive climate, the soil might still have the rock, but it will not have the water, air, animals, and dead plants that it needs to form and be proper soil. Because otherwise, the soil will be too thin, it won't be nutritious, it might just blow away literally. And the climate also impacts weathering with things like the temperature and the freeze-thaw weathering. So for example, if it's a colder area, there might be more freeze-thaw, so there might be more rocks being broken down to start that process of the soil being created. Okay? And then finally, I just want to point out that in mountainous areas, soil tends to not be formed anywhere near as quickly. So there's got very steep slopes, which basically means it struggles for the soil to form. And that's basically why we have such a low amount of vegetation in mountainous regions, because on these mountain slopes here, the soil can't get enough animals or plants or air into it. It starts to fall down and erode, and therefore plants don't grow on the sides of mountains. It's also the effect of gravity as well. I want to make that point clear really on there. Let's kind of recap then overall. So we're saying that firstly, the geology is a really important factor. Because of the geology of our parent rock type, that leads to the breaking down of rocks and the formation of the very basics of soil. That takes time, 1,000 years for 1 centimetre of soil. The climate is also vital because, as I've said, soil is not just made up of bits of rock, it's made up of living, so biotic factors as well. It's made up of dead animals, plants, water, air, all these different factors together. And the climate influences that. If the climate is warm and wet, generically, the soil might be thicker and healthier because there's more life in the soil, there's more water and air in the soil. Whereas in the tundra, if it's freezing, if there's no animal life there, it would be very difficult for that soil to reach the same quality. And then finally, the relief is important because soil forms best on flat land. Because if the land is too steep, the soil will not form properly. And if it does not form properly, we end up with a situation where there's very little soil and therefore very little vegetation for plants to grow. So to finish off then, guys, as always, there are 3 review questions I would like to answer. The first question is, explain why soil is full of nutrients. The second, explain how climate impacts soil. And thirdly, explain how relief impacts soil. When you're doing these questions, please feel free to rewind this video and go back to my explanation of these factors. So if you go back to the slide where I'm talking about nutrients, you can replay what I've said to help your answer. As always, I'd like it to be full sentences and uploaded onto Satchel 1 once you've finished watching this lesson. Once you've done that, if you need any support, as always, you can access the live Zoom, or if that is not available, you can leave comments on Show My Homework, which you can then get a response to.